Hello, geometry students. It's been a little while since I saw you guys, but I'm back with your lesson for section 10.4, surface area and prisms and cylinders. Missy McCarthy, Okemos High School math instructor. Objectives for this particular lesson will be to learn and apply the formula for surface area of a prism and learn and apply the formula for surface area of a cylinder. All right, so the parts of a prism would be the bases. In this case, the two bases are pentagons. The other parts of the prism would be the lateral faces, which are all of the rectangular faces. Those are considered the lateral faces. And then the height of the prism goes from the center of the upper base to the center of the lower base. Now this prism is what we call a right prism. This prism is what we call an oblique prism. It still has two bases. It has triangular bases, and it has three lateral faces. All of the rectangles are your lateral faces. And it also has a height, but because this is oblique, the height is on the measured as the altitude on the outside of the prism. So just keep in mind that there are other types of prisms. Our main focus is going to be on right prisms, this first one here. Okay, so let's talk about what lateral area and surface area of a prism is. So if we're thinking about or if we're looking at lateral area means nothing more than the area of the lateral surfaces or the area of the lateral faces. Area of lateral faces. And in a prism, the lateral faces are going to be all of the rectangular faces. This prism here is a triangular prism. It has a triangle on the top and a triangle on the bottom, and then three lateral faces. Surface area then would be the area of the lateral faces plus the area of the two bases. The area of lateral faces plus the area of the two bases. So if we look at this particular figure, here is the net for that figure. And if we wanted to find the area for the three lateral faces, I will abbreviate with LA for lateral area. It would be equal to H times A plus H times B plus H times C. Or if we factor out the H, we get A plus B plus C. But A plus B plus C is just the perimeter of this triangle, because this is A, or I'm sorry, they got it the other way around. This would be A. It's labeled here on the bottom for us. That's A, that's B, and that's C. So that's nothing more than the perimeter of the base. So our lateral area is going to be P for the perimeter of the base times the height of the figure. Now if we're going to find surface area, I'm going to abbreviate that with SA for surface area. It's the area of the lateral faces, so the perimeter of the base times the height, plus the area of the two bases. So I'm going to put 2 with a capital B here, where this stands for perimeter of base, and this capital B stands for the area of the base. Okay, so that would be the surface area and the lateral area of any prism. Okay, so here's just your little diagram illustrating what it is. The lateral area is for the right prism. Lateral area, they just use L equals the perimeter of the base times the height. And then the surface area is the same as the lateral area plus the area of the bases, or PH plus 2B. Now they just illustrate here a cube, because cubes or rectangular prisms are a little different in that sometimes it's difficult to tell what the base is because they're all rectangular. So for a cube, we can just say that the surface area of a cube is 6 times s squared, because the area of each face is s squared, and there's 6 of them. So the surface area is 6s squared. Okay, so let's look at cylinders now. Here again, you can have a right cylinder where the height makes a 90-degree angle with the radius, or you can have an oblique cylinder. Our focus is going to be on right cylinders. So let's look at the lateral area of a right cylinder. What is lateral area? Well, if you can imagine here this cylinder, this soup can, and we don't want to know the area of the whole thing. We just want to know the area of the label, the area around. So here is our label all by itself. Cut off the can and spread out. So let's look at what the area of this would be. We would use the area of a rectangle, which is length times width. Well, this guy here is nothing more than the height of the cylinder, or the height of the label. Now what's this? Well, we just took the distance around here, which is also known as the circumference, and we split it and we spread it out. So this is 2 pi r. That's the circumference of this can with the radius of r. Okay, so if we were going to find the area, it's base times height. So the area, or the lateral area of any cylinder, is going to be 2 pi r, that's the base, times the height, or just 2 pi r h. Now, if you're going to find the surface area of a cylinder, again, we already know that the area of the part around is 2 pi r h, and then you have an area here of pi r squared and an area here of pi r squared. So if you want to know the full surface area of any cylinder, it is just 2 pi r h plus 2 pi r squared. And that's it for surface area of a cylinder. Okay, so here's just a quick synopsis. The lateral area of a cylinder is 2 pi r h, and the surface area of a cylinder is the lateral area plus the area of the two bases, which is 2 pi r h plus 2 pi r squared. Just a little summary. All right, so let's find the surface area of this prism. So surface, this says find the lateral area. Lateral area is the perimeter of the base times the height. So the perimeter of the base, this is 9 plus 7 plus 9 plus 7, which is 2 times 9 plus 2 times 7. That represents the perimeter times the height, which is 14. So we would get 18 plus 14 times 14. So 18 plus 14 times 14, that's going to give us a lateral area of 448 feet. Please don't forget your units. Ooh, feet squared, my bad. There we go. Don't forget your units. Okay. All right, now we're going to find the surface area of a right prism, and this prism is a right regular triangular prism. All right, so the top of this prism is a regular triangle, or in other words, an equilateral triangle. And our drawing would look like that. So we've got to find the surface area. So we need the area of the, or the perimeter of the base, and it says the edges, the height is 20 centimeters, and the edges of the base are 10 centimeters. Okay, so the lateral area, I'm going to find that first, is just going to be the perimeter of the base times the height. The perimeter of the base is 30, the height is 20, and that gives us 600 square centimeters. So that's just the lateral area. Now we need the area of the bases so that we can double it and add it to our lateral area. Well, this guy is an equilateral triangle. Hopefully you remember how to find the area of an equilateral triangle. The central angle would be 120. Drop your perpendicular down. This would become 5. This would become 60, and that's 30. So that's 30, and that's 60 in there. And so we've got to find the apothem. So we would say the tangent of 30 degrees is equal to A over 5. So A is going to be 5 tan 30, which is 2. I'm going to say 887. So that's our apothem. And then we've got to find the area, which is 1/2 the apothem, which is 2.887, times the perimeter, which in this case we know is 30. So this is multiplied by 30 and then divided by 2. So we get the area of the base is 43.301. Okay, so our overall surface area now is going to be to add 2 of the bases plus the lateral area. So we've got 600 square centimeters plus 2 times 43.301 square centimeters. So I'm just going to double this on my calculator and then add 600 to it, and I get my surface area to be 686.603 approximately square centimeters. All right, let's look at the lateral area and the surface area of this right cylinder. So it says give your answer in terms of pi, so we don't need to multiply out times pi. We're going to have pi in our final answer. So for this particular one, we know the radius is 8 inches and the lateral area is 2 pi RH. So we've got 2 pi times the radius, which is 8, times the height, which is 10. 8 times 10 is 80, double that, so it's 160 pi square inches for our lateral area. For our surface area, we just have to add the 2 areas for the top and the bottom. So our surface area is going to be our lateral area, which is 160 pi, plus pi r squared, and we have 2 of them, so 2 times 8, times pi times 8 squared, which is 160 pi, plus double 64, which is 128 pi. So 160 plus 128 is 288 pi, and our units are square inches. So this is our lateral area, and there's our surface area. Okay, here's another one. Find the surface area of the right cylinder described below. So the cylinder has a circumference of 2 pi r. I'm sorry, not 2 pi r. My goodness. It is 24 pi centimeters, and the height is equal to half the radius. So the height is equal to half of the radius. So we've got to find the surface area, so we need the lateral area. I'm going to try to draw this out just so we have it. Okay, so this is equal to half r. This is r. And the circumference is 24 pi. So 24 pi is equal to 2 pi r. So we divide both sides by 2 pi. And those will cancel. And so the radius is equal to 12. We got that. So since the radius is 12, we know that the height of this thing is 6 units. And so then if we want to find the surface area is going to be equal to the lateral area, which is 2 pi RH plus 2 times the base, pi r squared, or 2 times the area of the base. So 2 pi RH is going to be 24 pi times 6. So 24 times 6 is 144 pi, plus the area, which is 2 pi r squared. R is 12, so that's 144. That's 288 pi. And if we add those together, we end up with a surface area of 432 pi square centimeters. Okay. All right, here's our last one, and this one is finding the surface area of a composite figure. So we're going to have to put together quite a few things that we know. One of the things that we know is that we can find the surface area of this entire rectangular prism. But that's not all of the surface. The rest of the surface would be the inside here where this cone, I'm sorry, not cone, where this cylinder is. Now we don't want the whole cylinder for surface area. We only want the lateral area because it has a hole cut out here, a hole cut out here. So to find the surface area of this composite figure, we're going to have to find the surface area of the prism. We're going to have to add the lateral area of the cylinder, and then we're going to have to subtract out 2 pi r squared for the areas of these bases that we don't want to include in this surface area of the prism. Okay, so the surface area of the prism is going to be the lateral area, which is the perimeter. 24 plus 16 doubled. 24 plus 16 times 2. So again, it's the perimeter times the height. That's going to be the surface area of the prism. Oh, plus, I'm sorry, that's the lateral area of the prism, plus 2 times the area of the base, plus the lateral area of the cylinder, which is 2 pi RH, minus 2 pi r squared. So I'll just write everything here. Surface area of the prism. So we've got 80 times 20 plus 2 times the area of the base, which is 24 times 16, minus the surface area of the cylinder, which is, or the lateral area of the cylinder, which is 2 times pi times 4 times the height of the cylinder is 20, minus 2 pi times the radius squared. So I'm going to simplify this as much as I can. That's going to give me 106, that's going to give me 1600 plus 2448 times 16 plus 768 minus, that would give me 80, that would give me 160 pi, and then minus 4 squared is 16 times 2, which is 32 pi. All right, almost there. So if we sum those up, we end up with 2368 minus 192 pi. Now I'm wondering why I'm subtracting that. I should not be subtracting that. I'm sorry. This should be adding. This should be adding. And that would not be that. It would be 160 minus 32, which would be plus 128 pi. And this whole thing is in square feet.